Today, let's explore something truly fascinating, the story of a supernova and how it sparked the beginnings of our solar system. It all began not within a distant cloud, but near it. A dying star exploded, a phenomenon we call a supernova. This dramatic event often occurs when massive stars reach the end of their lives. The shock waves from this explosion traveled through space and reached a nearby solar nebula, triggering instability. This nebula, a massive cloud of gas and dust, started to collapse under its gravity. Within the cloud, particles of gas and dust began compressing and swirling. Over time, the nebula transformed into a flat, rotating disk, a protoplanetary disk. As the name suggests, this was the precursor to the planets. The center of this disk grew increasingly hot and dense, eventually forming a protostar, which would later ignite into the sun. The process of nuclear fusion began. Hydrogen atoms fused into helium, releasing immense energy. This reaction is the very reason the sun shines and continues to provide light and warmth to Earth. About 4.6 billion years ago, most of the material in the solar nebula collapsed into the sun, leaving just 0.2% of the mass to form everything else: the planets, moons, comets, and asteroids. But how did planets emerge from this swirling disk of dust? It all began with tiny particles sticking together due to static and chemical forces. Over millions of years, these particles grew into clusters, then into kilometer-sized bodies known as planetesimals. Eventually, gravity took over, pulling these planetesimals together to form larger objects called protoplanets. This process, called accretion, was first proposed in 1969 by Soviet astronomer Viktor Safronov. Though initially overlooked, his work is now a cornerstone of our understanding of planetary formation. Through powerful telescopes, scientists have observed this process in other solar systems, confirming that dust particles can accumulate into larger bodies over millions of years. Meteorites offer further evidence. They often contain chondrules, ancient remnants of the solar nebula, providing a snapshot of the time before planets existed. Now let's focus on Earth's journey. During its early years, Earth was a molten, chaotic place, frequently bombarded by planetesimals and protoplanets. These collisions generated immense heat, creating oceans of lava. Gravity shaped the growing Earth into a sphere, and over time, the planet differentiated into layers, crust, mantle, and core. But here's something incredible. Those fiery collisions also delivered water to Earth. Comets and asteroids rich in water ice played a crucial role in filling Earth's oceans. As the planet cooled, water vapor condensed and fell as rain, eventually forming vast bodies of liquid water. This brings us to an intriguing question. How did the Moon form? While theories like capture and co-formation were proposed, the most widely accepted explanation today is the giant impact hypothesis. According to this theory, a Mars-sized protoplanet named Theia collided with the young Earth, ejecting a massive chunk of material that eventually became the Moon. Remarkably, the Moon's formation had a profound impact on Earth. It stabilized Earth's axial tilt, giving rise to seasons, and influenced the development of tides, which played a critical role in the evolution of life. As Earth transitioned from the chaotic Hadean Eon to the Archean Eon, the planet began to cool and stabilize. Volcanic eruptions released gases like water vapor and carbon dioxide, creating a primitive atmosphere. Rain helped form the first oceans, and liquid water became a crucial component for the emergence of life. Earth's structure also became more defined. The heavy elements like iron and nickel sank to form the core, while lighter elements like oxygen, silicon, and aluminum floated to the surface to create the crust. This differentiation gave rise to the layers we know today. Interestingly, Earth's magnetic field, generated by the churning of molten iron in the outer core, protects the planet from harmful solar radiation. Without it, life as we know it wouldn't exist. The story of Earth's formation is a testament to the delicate balance of conditions that make life possible. The right distance from the sun, the perfect size, a protective magnetic field, and just the right amount of volcanic activity. All these factors came together to create a habitable planet. This incredible journey reminds us how rare and precious Earth is. Protecting our planet is not just an obligation, it's an acknowledgement of the extraordinary events that made our existence possible. Thank you for joining me on this journey through time. If you'd like to learn more, check out my video on the evolution of life and how humans came to be. Until then, let's cherish this amazing planet we call home.